In this video, we're going to be taking a look at agility and process. Specifically, we're going to continue our discussion on prescriptive process models, but now take a look at agile process models. If you recall from our last lecture, prescriptive process models were very rigid and structured. Agile process models try to change that and account for the changes that we see in the real world. Without further ado, let's get into it. And as we talked about with those last slides, there are some issues with the prescriptive process models we covered, and all prescriptive process models in general. And those all stem from the real world being fluid. Requirements change, market conditions change rapidly, end users' needs evolved, and new competitive threats emerge. And the problem with these prescriptive models is that they tend to be too rigid and structured to deal with this change effectively. So agile methods aim to reduce the cost of this change. When we're talking about cost, we usually mean time when we're talking about software development. We want to minimize the time impact of these changes. And we also want to add a human element that the traditional models are missing. Another thing agile methods really focus on are being lightweight. And by this, I mean lightweight in terms of documentation. We really only want documentation and modeling for things that we're actually going to use and people are going to look at again. Making piles and piles of the best documentation in the world is great, but it's not going to be helpful if that just goes in a filing cabinet and no one ever looks at it. So we want just a sufficient amount of documentation. So what is agility? Well, in terms of software, it's effective response to change that's both rapid and adaptive. It also means drawing the customer or the stakeholders onto the team, and that means frequent communication with them and making them part of the process. It also means organizing a team so that it's in control of the work performed. So the team should be empowered to make certain decisions about the software and what they're working on day to day, so long as it's fulfilling the overall goals and objectives of the project. It also means rapid incremental delivery of software, sort of like we saw with prototypes and the other models. And the goal here is to reduce that cost of change. So when we're talking about prescriptive models, we tend to see a curve that looks something like this when we're talking about the cost of change versus how long we are in the development process. So the further you are along in development, the higher that cost of change is going to be. The reason why is a lot of those prescriptive models, especially things like the waterfall model, didn't really have a feedback mechanism to deal with the change. They only sort of dealt with the stakeholders at the beginning, during the communication, and at the end during the deployment. So if the change happens somewhere in the process, there's going to be a really big cost to going back and doing it again. So with Agile, the goal or the idealized curve would be something like this, where at the start it's a little bit cheaper to have change, but then otherwise it sort of stabilizes out of a flat line with a relatively low cost. However, in real life with Agile methods, we see something that looks a little bit more like this, where we still get a big benefit over the prescriptive models. However, we still tend to suffer from cost of change going up closer to the end of the project. And you can kind of see why that would be if you just think about it a bit. Even if you have the best Agile method, you're still, if you're at the very end of the project and the customer comes to you wanting a massive change, there's going to be a cost to that. It means you're going to have to restart your cycles, you're going to have to do a new increment, and if that change is big enough, it means that you're going to have to throw out old prototypes. So no method is going to be perfect, but we tend to see Agile methods handling change better than prescriptive ones. So the Agile process is built on 3 key assumptions. And those are, it's difficult to predict which software requirements will change. So we may have a big list of software requirements that we gathered for the communication activity. And while we can make some educated guesses, it's hard to tell what's in the mind of the stakeholders, what requirements might change because the market changes, their needs changes, or what might change because they might not be technically feasible. The second key assumption is that some activities should be done in tandem or at the same time. The reason for that is that way we get better feedback and coordination between those activities. The third key assumption is that analysts, design, construction, and testing are not predictable. For example, maybe you just planned in your designs to use a certain API or library, but when you started construction, that actually didn't fulfill your needs. It didn't get you what you wanted. So you have to switch to a different one, and that's going to cause redesign costs and things like that. Another example would be maybe during design you thought something would be trivial to solve, but when you actually got down and trying to build it, it didn't turn out to be that easy. So with all these assumptions, they all are dealing with uncertainty. Uncertainty due to change, uncertainty due to our plans being incorrect, or uncertainty due to errors earlier on in the process. So we need adaptability to deal with that uncertainty, and that's what Agile's trying to be all about. So as I alluded to, the answer to this uncertainty is process adaptability. So our processes we use must adapt incrementally based on customer feedback. So we can't just have everything changing all at once completely. That would mean nothing would ever get done. Instead, we want to deal with change incrementally at certain points in the process. Another big part of the Agile process is the rapid development of software increments as executable prototypes, usually within 2 to 6 week periods. And these prototypes are important because they act as a catalyst for customer feedback. Customers don't always know what they want in the requirements gathering phase, and when they actually have something in front of them, it helps them understand what their real requirements are, what they actually like or don't like about the software. So getting that feedback often and frequently as you go can help to deal with changes. You don't wait till the very end and show it to the customer and then they want a big change and you have to go back. Instead, you're constantly showing them the software as you're developing it so they can give feedback and guide the process. So these Agile processes we're going to be discussing tend to work best for small teams. So if you're like a big company like Microsoft working on a massive monolithic thing like an operating system like Windows, they might not be the best method unless you can really compartmentalize or break the problems down into specific things that smaller teams can work on. And these teams must have some certain key traits among the people to be effective in an Agile environment. There's competence. You need experienced developers that know what they're doing. They need to have a common focus. They have to have collaboration, decision-making abilities, fuzzy problem-solving abilities, mutual trust and respect. That's actually one that you might not think of, but it is a really big one. You have to really be able to trust that the other people on your team are getting done what they say they're going to be getting done. And this is going to be something that you're going to come across in your project, I'm sure. And they also have to be very self-organizing. Agile teams try to give a lot of the power to the team itself, the development team, rather than strictly managed by a project manager. So they do have to have the ability to plan out themselves what they're going to be doing, what things they're working on, because those prototypes are going to be developed rapidly, so everyone has to be on the ball. And they're going to need to have discipline to stay committed to those schedules, those deadlines, and those milestones. There are costs, however, to Agile processes. It's not all sunshine and rainbows. And usually this is in terms of predictability and manageability of the project. So these Agile methods that we're going to be looking at times can seem rather chaotic and uncontrolled. This is particularly true to people that are sort of set in the old ways and the traditional models, or management that's very hands-on and likes to have fine control of their development teams. So it can be a hard sell if you're trying to introduce this to an organization or team members that aren't used to an Agile process. And like those traits we mentioned before, if the people on the team don't have those right traits, it is very easy to have the whole Agile method collapse back to just no process at all, no control of what anyone's doing, and no sort of coordination. So it does require a team that has discipline and leadership that is familiar with the Agile process and has the ability of keeping everyone on task and on track. So there are a few key agility principles that we'll cover here, and these come from the Agile Alliance, and I have their URL up there on the slide. So the Agile Alliance is a global nonprofit membership organization, and that was founded on the Manifesto for Agile Software Development that our textbook talks a little bit more about. And their goal is to support people and organizations to explore, apply, and expand Agile values, principles, and practices. They do sort of a lot of workshops and professional development related to Agile methods. So here's some of the principles that they profess. So the first one is our highest priority is to satisfy the customer through early and continuous delivery of valuable software. So that's getting those prototypes out there early and in a continuous way, so there's continuous feedback from them. Number 2 is welcome changing requirements, even late in development. Agile processes harness change for the customer's competitive advantage. So we haven't talked much about competitive advantage. It's more of a business subject, but that's sort of like the business's ability to have some advantage over its rivals. If you're able to change your software that you're using at a drop of a hat, that would give you a significant competitive advantage. So a software team implementing processes that are able to harness change well, deal with change well, can give that organization a competitive advantage over its business rivals. Number 3 is deliver working software frequently, from a couple of weeks to a couple of months, with the preference to shorter timescales. So once again, like I was saying, we're trying to get those prototypes out there frequently, so the customer has say in those increments as the process goes along. Number 4 is business people and developers must work together daily throughout the project. So we won't want just developers involved in the process, we also want stakeholders. So those would be the business people in this case. Number 5, we want to build projects around motivated individuals and give them the environment and the support they need and trust them to get the job done. So the big thing here is trust them to get the job done. So we don't want management that micromanages. Instead, we want developers to have the ability to identify the tasks that they need to work on and get that done without having a big overhead, like things like too long meetings, things like not being able to work on the things they think are important. You have to trust your development team to know what they're doing and to be able to get that work done on time. Number 6 is the most efficient and effective method of conveying information to and within a development team is face-to-face communication or conversation. And this is why I'm really pushing for face-to-face meetings with your group. And in the past, this used to mean actual in-person meetings, but in partly due to the pandemic, this started to expand out more to face-to-face interactions that could be over Zoom, for example. And a big reason for this is you've probably experienced this before where you're talking to someone through something like email, send a message, then you have to wait a few hours for the response, then something they didn't understand or not, then you have to send an email, wait another few hours. It's that in a 15-minute conversation face to face, you could probably convey, understand, and explain more information than you could be through like a day's worth of emails. So we want fast, effective communication. And a good way to facilitate that is with face-to-face conversations. Number 7 is working software is the primary measure of progress. So instead of measuring progress by certain milestones or certain documents being produced, we want to measure our progress on the project by the actual software. Is it passing the tests? Is the customer accepting prototypes? And things like that. So we wouldn't want to measure progress like things like lines of code or something silly like that or other metrics. The actual metric for progress should be software fulfilling requirements and tasks. So number 8, Agile Processes promote sustainable development. The sponsors, developers, and users should be able to maintain a constant pace indefinitely. So we want a process that's actually maintainable. We don't want to put a crazy amount of work on our developers and think that, oh, we could do that next time when we're really burning them out. We want a process that we can repeat over and over again with every project for hopefully indefinitely and still get continuously good results. Principle number 9 is continuous attention to technical excellence and good design enhances agility. We want to focus on producing a high quality product. Number 10 is simplicity. The art of maximizing the amount of work not done is essential. And I talked about this a little bit. We don't want to be producing documentation and models and things that we're not actually using. We want just sufficient to accomplish our requirements. Number 11, the best architecture, requirements, and designs emerge from self-organized teams. And number 12, at regular intervals, the team reflects on how to become more effective and tunes and adjusts its behavior accordingly. And that's the whole idea behind continuous improvement. After we've gone through a cycle or we've completed a project, we want to take time to look back at it and see what we did well, what we did wrong, and try to improve it next time. Remember, this isn't just like a strict prescription of methods to complete a software project. We have to adapt it to our own team, our own organization, and our own objectives. So we want to always be improving how we're adapting that process. So enough of that, let's now take a look at some specific Agile methods. And the first one is Scrum. So if you're familiar with rugby, This name comes from rugby. It's when a group of players form around the ball and teammates work together to move the ball downfield. So in terms of this agile process, this is specifically referring to certain meetings that are going to occur in the process that we'll get to in a second. So in Scrum, the core framework activities are called requirements, analysis, design, evolution, and delivery. And these pretty much fit in with those generic ones that we've seen before. Requirements would be communication, analysis would be planning, design would be modeling, evolution would be actually the creation, and delivery would be deployment. The difference of naming comes, there's a little bit of a different focus. So communication, the pure focus is on requirements gathering. For example, construction, if we call it evolution because we're trying to evolve a prototype to get more complex to more complete as we go on. Tasks in each framework activity take place in a short time box called a sprint, normally 2 to 4 weeks in length. And the Scrum team consists of a few specific members. The first one is the product owner. So this is usually a key stakeholder, and it's someone that's responsible for maximizing the value of the product resulting from the work of development team. And their key responsibility is going to be managing something called the product backlog that we'll get to shortly. So really, this is the stakeholders representative that's actually part of the team. And that helps us get that continuous feedback. The next is the Scrum Master. So this is a facilitator to all members of the Scrum team. They run the daily Scrum meetings, remove objectives identified as obstacles by team members, and they deal directly with the product owner. They also sort of act as sort of almost a shield from higher management to sort of be an intermediary between them and the development team. So the developers are free to deal with what they do, coding and planning and design. Now, organizations tend to deal with Scrum Master a little bit differently. In some cases, it's a permanent job where that person's sole job at that company is being the Scrum Master for one or more teams. In other organizations, it's just a developer that has a few additional responsibilities. And in some, it switches project to project. Next is the development team. This is usually 3 to 6 people. Remember, these agile methods work best for small teams. So they create software increments and decide when increment is done and when to present it to the product owner. So one thing you might be wondering is, if this is only for about 3 to 6 developers, how could it ever be used for something big, like modern video games, for example, probably have teams in the hundreds? Well, the key thing is breaking your problem, or something like a video game, into many small compartmentalized components. And that way you can have specific teams for each one. You might have a team, for example, in the case of a video game, dedicated to graphics, one dedicated to the game engine, one dedicated to designing the dialogue and characters. You might have some teams solely dedicated to just developing tools that the other developers will use to create that game. Now, there's a few artifacts that the Scrum method emphasizes or creates. The first one is the product backlog, which is a prioritized list of product requirements. And these items can be added to the backlog at any time, so long as they have the approval of the product owner and the development team. This is in one way that Scrum handles change. So at any time, changes to requirements can be added to the product backlog. And it's the responsibility of the product owner to order the items in the product backlog based on the value or the importance of them to the organization or to the stakeholders they represent. The next artifact is the sprint backlog. And this is a subset of the product backlog. That means it's going to contain some of the items from the product backlog, but not all of them. And what this sprint backlog represents is the set of items that are going to be completed during the current sprint. A sprint is a set period of time, like we said, about 2 weeks, where you're actually working on constructing the prototype. So that means the sprint backlog is basically the requirements that you want to get implemented during the sprint. And an important rule is that items cannot be added after the sprint starts, unless the sprint is completely canceled and restarted. Remember that we said Agile methods want to deal with change incrementally. Can't be a complete chaos where the product owner is just throwing new things in the backlog while you're actually working on it. That would make sense. So we have sort of like a frozen backlog for the duration of the sprint. Product owner could still add things to the overall backlog, but at least what you're working on for that 2-week, 4-week block is going to be static and unchanging. And the last artifact is the code increment. So that's the union of all the product backlog items completed in previous sprints and all sprint backlog items to be completed in the current sprint. So that's basically your current prototype to date and what you've implemented from the backlogs. So Scrum really emphasizes a lot of face-to-face meetings, though it does try to make the more frequent ones short as possible. The first one is the backlog refinement meeting. This is where developers are working with the product owner and the stakeholders to create that initial product backlog. And then everything in that backlog is rated by importance of the product owner's business needs. The next meeting is the sprint planning meeting. So this one is held prior to starting a sprint. And the idea here is that the product owner is going to give the team goals for the next increment, and the Scrum Master and the development team select items from the product backlog to add to the sprint backlog. Remember, that's what they're going to be working on in that sprint, and it's frozen once that sprint starts, so you can't make any changes to that backlog until the sprint is done or canceled. The next one is going to be the daily Scrum meeting. So this is going to be one that happens every day, whereas like the sprint planning meeting only happens once a sprint, so maybe every 2 weeks to 4 weeks. Well, the daily meeting every day. And because it is a daily meeting, it is tried to limit to 15 minutes maximum. We don't want to use up all the developer time in meetings. And the purpose of this meeting is to ask 3 questions to each member of the development team. The first one is, what have you done since the last meeting? And the next one is, what obstacles are you encountering? And the last is, what do you plan to accomplish next meeting? So this does a few things. It keeps the developers accountable for what they're doing. It keeps everyone coordinated to know what each other are working on. You don't want people redoing the same efforts. And it also lets the Scrum Master understand what obstacles are in the way that they need to work on. Maybe they need a certain tool. Maybe they need a change to their development environment. Maybe they even need something like a new, more powerful server. And then that Scrum Master can work on getting that from higher up in the organization, while the developers work on what they're good at coding. So the Scrum Master tries to clear those obstacles by the next meeting, and developers try to finish what they plan to accomplish by the next meeting. But it's important to point out these are not problem-solving meetings. They're not getting together and discussing how they're going to solve something or what problems they're having with solving it and working together. Instead, those would occur offline and only involve the developers actually involved in that problem. There's 2 more meetings. One is the sprint review meeting, and that occurs at the end of a sprint. So the prototype they make, or the demos, are delivered to the stakeholders for approval and rejection. So during that meeting, the product owner and possibly some other stakeholders are given the prototype which showed the demo, and they have to provide feedback for the next sprint. And during this meeting, new features are commonly added or removed from the product backlog based on the feedback from the stakeholders. This meeting would then lead into a new sprint planning meeting, and then the sprint process would start again. There's also a sprint retrospective meeting. So this is another meeting that occurs after a sprint is complete, but it usually only involves this team, so the Scrum Master and the development team. And the purpose of this is to sort of decide how we can improve the process. Remember, one of the Agile principles was that we wanted to have methods for continuous improvement. So they discuss a few things like what went well, what could be improved, and what the team will commit to improving in the next sprint. This meeting is run by the Scrum Master, and they would take that feedback and try to use it to develop the process better for the next sprint. So not only are we developing software, and hopefully that software is getting better, we're also developing the processes and procedures that the team and organization uses as we're going. So hopefully we're making good software, and we're also making our whole process for making that software better as we go. And this is sort of a visualization of Scrum. So on the left here, you see we have the product backlog that's prioritized by the customer for the product owner. And then we take certain items from that product backlog and we put them into the sprint backlog. Once we start a sprint, the team starts working on those features. And every 24 hours, every day, there's a 15-minute daily Scrum meeting. And after the end of the sprint, we then have those product demos. And that new functionality is demonstrated. It says 30 days here, but again, it can range from 2 weeks to up to 6 weeks. From the examples I've seen in real life, a lot of teams now seem to be focusing on 2-week sprints, but again, it's a process that has to be adapted to your individual needs. So overall, the pros are product owner set priorities by organizing that backlog. The team makes its own decision making. Once that sprint started, everything's locked in and it's up to the team to decide how they're going to implement it and how they're going to accomplish those features. The documentation is really lightweight. We only want to make the documentation that's necessary, and it supports frequent updating. The product owner can put new things on the backlog whenever they want. Product backlog, that is. And the cons are it's difficult to control the costs of change, or, for example, the stakeholder or the product owner could keep sending it back for a new sprint. That means going around and around, taking more time. And it may not be suitable for large teams. We talked about how you'd have to break a big problem up. Imagine if you had a team of 200 doing a daily meeting like that, where you asked every single person those questions, would probably take the whole day, not 15 minutes. So we really do need to keep it limited to a team that's small enough that could handle things like those meetings. It also requires team members that are very familiar with the process and understand the benefits and the reasons behind why they're doing this. So the next method we're going to look at is called extreme programming, or XP. And extreme programming encompasses a set of rules and practices that occur with the context of 4 framework activities. So this one focuses on 4 activities rather than the 5 generic ones we saw before. Those are planning, design, coding, and testing. So the main focus of the planning activity is the creation of user stories. So user stories are a type of documentation that describes the required output, features, and functionality for software to be built. User stories are written by the customer, and for example, they could be placed on index cards or in some sort of online electronic system. And for each one, a value is assigned and estimates for how long that new story would take to implement in the software. They also commonly have acceptance criteria attached. We'll get into that in a sec. So teams take each story and assess the story and assign a cost. The cost here isn't in dollars, rather it's in development time. So number of weeks, number of days to actually implement that story. Stories are grouped together to form a deliverable increment. So this is sort of like the sprint backlog in Scrum. Instead, these are like a group that they're going to implement during the next construction phase. So then the delivery date for the increment is decided. At first, that's usually just based on the cost from all the user stories that are going to be delivered in that increment. But then after the first increment is completed, a project velocity can be calculated, which sort of makes that more and more accurate estimate each time. So we get a better idea of the delivery date each increment of the software. So I did mention user stories there. This is an example template for what a user story might look like. So user story is usually formed in the form of as a blank, where blank is a type of user or actor in the system. For example, it might be just as a user or as an administrator. If it was something like a learning management system, it might be as a professor or as a student or as like a grade administrator. I want to perform some specific task. And you also need to have some reason or goal associated with why you want to perform that task. So to keep on going with the learning management system example, might be as a student, I want to access my assignment grades so that I can assess my current standing in the course. So acceptance criteria, which is often attached to user stories, is what actions should actually be carried out by the system and what outcomes should be observable in the system. How does the state of the system change if this user story is performed? And they take the form of given that blank, when blank, then blank. So it would be given that some context happens, when some action is carried out, then some observable change in the system should happen. So let's take a look at an example. So in this example use story, someone forgot their password and they want to reset their password link. So the user story might be, as a user, I want to be able to recover my password to my account so that I can access my account in case I forgot my password. And user stories should be relatively simple like this. You can have a lot of them, but you want them to be very obvious of what the intent is. And the acceptance criteria in this case might be given that the user navigates to the login page. When the user selects the forgot password option and inputs an email, then the system sends a password reset link to the entered email if it is valid. So you also could have multiple acceptance criteria attached to a user story. So you might also want one that says what happens when they actually click the link on that email. You also notice that I have a title for this, a priority, and an estimate. So the priority and estimate in this case are just made up because it's just an example. But what would happen is the stakeholder would be assigning priorities to each of these use stories based on how much value or how badly they need them in the system. And the developers would be putting in that estimate for how many weeks they think it would take to actually implement that user story. So continuing on with extreme programming, the next activity is design. And this generally follows the KISS principle. That's keep it simple, stupid. And it encourages the use of CRC cards, or class responsibility collaborator cards. And this is a mechanism to think about software in an object-oriented context. So CRC cards identify and organize object-oriented classes that are relevant to current software increments. And we'll talk about this more when we get into requirements and chapter 8 of the textbook. So the CRC cards are the only work product from the design activity or other documentation. But one thing that is encouraged is to think about design both before and after coding commences. What they mean by this is something called refactoring is encouraging. So refactoring is the modifying or optimizing of a code in a way that does not change any of the external behavior. So you may have done this yourself when you're working on an assignment or a personal project. You write it and it's kind of getting bloated and all over the place, and you just want to rewrite that code to be a little more elegant and neat, maybe remove some redundancy, make it a bit cleaner. So that would be refactoring the code. You didn't actually change what the code does, you just made the code quality higher and the design better. So this is what it means by design occurring, both before and after coding. The next activity is coding. And the big emphasis here is that unit tests are created before the code. Unit tests, again, are tests that just focus on certain components of the code. Maybe they just test one function, put in certain inputs, get certain outputs, and check that they make sense. And this is usually done through automated means. That means using tools to automatically run this test, as opposed to having a human there, putting in some input, and then manually checking if it's correct. And when we develop software in this way, where we're writing the tests first, this is something called test-driven development, or TDD. The other thing it encourages during the coding phase is pair programming. This is when two people are working together at a workstation for real-time problem solving and quality assurance. So there's a number of different ways pair programming can be implemented, different styles different organizations can take, and it usually depends on how the team has adopted it to their own processes. So in an unstructured style, there's two people at a computer, and they sort of switch back and forth between who's doing the coding and who's doing sort of the quality assurance, just based on the flow of the team, based on how it's going. So there's not one set person doing one thing. In driver-navigator approach to pair programming, one developer sets the architecture or strategic direction, and the other actually implements the decisions as code. The person who sets those directions is also doing sort of quality assurance, making sure that what they're doing makes sense. And then the last one is ping pong. So in ping pong pair programming, it shifts rapidly back and forth between the two developers, like a game of ping pong, where the software is the ball. That's commonly two people sitting close together working on similar or the same problem, but with two computers instead of just one. One thing I will note about pair programming styles is that they can be a little bit stressful on programmers. Having someone sitting there the whole time looking over your shoulder, sort of evaluating what you're doing, does kind of lead to burnout pretty fast. So when implementing paired programming, it's important to also make sure that it's sustainable. That is one of the Agile principles. So some teams sometimes only do pair programming for certain parts of the day or rotate who's doing it, just to give a little bit of a break from it because it is a bit harder than programming on your own in some regards. So the last activity in the XP framework is testing. So all unit tests are executed daily, preferably in an automated fashion. Acceptance tests are defined by the customer. These typically come from the user stories and those acceptance criteria attached to them, and they're executed to access customer visible functionality. So acceptance tests, also known as customer tests and functional tests, validate the customer's view of the application. They're distinct from unit tests, which validate the programmer's view of the software internals. So here we can see a bit of a visual representation of this process, and you'll notice that there is refactoring on that code. So we have sort of a feedback loop there that just incorporates design of refactoring in the actual coding process. So there's some pros and cons to this method. The pros are it emphasizes customer involvement, establishes rational plans and schedules, and high developer commitment to the project. It also reduces the likelihood of product rejection. The cons are, just like with other prototype processes, there's that temptation to ship a prototype. And it requires frequent meetings about increasing costs, allows for excessive changes, and depends on a highly skilled team of members. The next Agile methodology we're going to take a look at is the Kanban framework. So this is a lean methodology for improving any process or workflow. It doesn't necessarily have to deal with software. In fact, it was originally developed in Japan for just-in-time manufacturing. And it has a focus on change management and service delivery. So Kanban board shows all of the project's tasks, their current statuses, and helps track their progression over time. And it tries to limit the amount of work in progress at any given time. So in terms of software, developers are only focusing on certain tasks rather than a large set of them. So a Kanban board is a visual representation of the tasks that need to be completed. The squares here each represent a task, and generally they move from left to right in the board as they're completed. So they might start off on the left in the backlog, and then once they're selected for work, maybe in the next sprint, they're moved to selected, and when they're in the analysis phase, they're put in the analysis box. Then when they move to development, they're put in the development box, and then to testing when they're in the testing phase, and then move to done when they're done. So the idea here is to have most of your squares in backlog and done, and only have a few moving between these phases while you're working on them. So here we see a little bit more of a simplified version of Kanban. It is up to teams to adapt this as always, so they might have different categories. So in this variant, the backlog is tasks waiting to be selected for development. To do would be tasks selected for development that are waiting to be worked on, and in progress are tasks that are currently assigned and are being worked on. Done are tasks that have been completed. And like I said, each organization has its own needs and goals, so they are going to have their own sort of categories and columns on this board. So Kanban also recommends daily meetings called Walking the Board. In these meetings, teams identify any items missing from the board that are actively being worked on, and teams try to advance any items they can from where they currently are to the done column. The goal is to advance high-value or high-risk items first to the done column, as this lowers the overall risk of the project. An important thing here is this Kanban framework, and these Kanban boards, can be easily combined or used with any other Agile development practices. So, for example, you could use this with Scrum or extreme programming. Any sort of Agile methodology will probably be compatible with Kanban framework. And like I said, this isn't limited to software, so this is even something you could use in your own personal life if you're working on some big personal project, maybe an undergrad thesis or something like that. You could do the same thing to keep track of your progress and keep everything on track. So there's a few pros and cons here. It lowers budget and time requirements, allows early product delivery, process policies are written down, and continuous process improvement. The cons are teams' collaboration skills determine success, poor business analysts can doom the project, and flexibility can cause developers to lose focus. The last Agile method we're going to talk about are DevOps, which comes from the word development operations. That's sort of the combination of software development, the dev part, and IT operations, or the ops parts. and it attempts to apply agile and lean development principles across the entire software supply chain. So DevOps involves several stages that loop continuously. The first is continuous development. These are deliverables that are broken down and then developed in multiple sprints. Continuous testing, automated testing tools used prior to integration. Those would be things like the unit tests, accessibility tests that can be automated. Continuous integration, that's a big part of DevOps, is being able to add this new code that we've developed into existing running code. That makes it really good for systems that are alive or being maintained. Continuous deployment, which is integrated code is deployed to the production environment. So this is after you've added it to the existing code, you're actually putting it out in your environment. So for example, this was OWL, it would be adding a new feature, functionality to OWL, making sure that integrated correctly, and then launching it on the servers, making it live for everyone. And continuous monitoring, where the team's operations staff members proactively monitor software performance in the production environment to make sure everything's going correctly and to know any bugs or defects that they notice. So DevOps is really focused around those kind of systems where you can have continuous deployment and updating. So sort of things like Web 2.0 sites, things like OWL, learning management systems, things that usually have like this continuous high maintenance to them. And a visual representation of it is here. So you're going for planning, coding, building, testing, and then reintegrating into the existing code, deploy, operate, monitor, and then go back to planning to plan new features to add in the next sprints. So there's pros and cons to this, like with everything. Pros are reduced time to code development. Team has developers and operations staff. Well, that's one of the big differences between this and the other methods we've seen, which is that the other methods tend to just have developers and stakeholders rather than things like IT operations staff. Team has end-to-end project ownership and proactive monitoring of deployed products. So we're constantly monitoring what we've actually deployed, helps us to find issues, defects, bugs sooner. It's not like we're sending it away necessarily and just waiting for a user to eventually report it to us. So the cons are there's pressure to work on both old and new code, heavy reliance on automated tools to be effective, and deployment may affect the production environment. That's a big one. You push the new code and there's something wrong with it, then the system's going to go down for everyone. And it requires an expert development team, which is a common thing we see with most of these agile methods. And that's all I have for you in this video on agility and process. Our next video is going to be about the recommended process model that our textbook authors suggest. Thank you for watching and have a great day.